Hi, welcome back to this channel. In previous video 1 to video 4, we already discussed 8.1 reaction rate. So in this video, we will focus on 8.2 collision theory and transition state theory. And don't forget, we still have 8.3 factor affecting the reaction rate. Before we start this video, let's check out what are the learning objectives for this 8.2. So basically, you will notice there are only 4 learning objectives, and all these 4 learning objectives are involved C1 and C2, which basically are covered in lecture. So first we need to know what are the collision theory, and then we need to know the meaning of activation energy. In Bahasa we call tenaga pengaktifan, and then we need to explain the theory for the transition state theory, and then we have to draw the energy profile diagram. Let's start with the first learning objective, collision theory. So basically the collision theory is used to explain the rate of reaction. So, and then what is the collision? So, basically a chemical reaction will be happen when the reactant collide with each other, and then the bond will be break down. And then they will continue to collide to form a new bond, which means product is formed. However, not all the collision can cause reaction happen. Collision in bahasa is pelanggaran. Only effective collision will cause the chemical reaction happen. So effective collision in bahasa is called pelanggaran berkesan. Basically, there are 2 requirements to cause effective collision, which actually you already know in SPM. So this is just recall. So first, the molecules will collide with correct orientation, which focus to the reactants. So in this diagram, basically, the molecule can collide in 4 methods, but only one method will be considered as correct orientation. Next, the second requirement is the molecules, which again also refer to the reactant, must possess the energy equal or greater than the activation energy. Okay, so you can simplify the terms equal or greater than using this symbol. So what is the activation energy? Energy required to initiate the chemical reaction. Okay, in bahasa, to initiate, we can consider it as memulakan. So if the energy possessed by the molecule is low, so even though the molecules are collide with the correct orientation, chemical reaction also will not happen. Now let's check out how to identify the activation energy through the energy profile diagram. So basically this is the energy profile diagram, and then this is showing an exothermic process. This one R is represent the reactants, and then P is represent product. So activation energy is energy that used to initiate a chemical reaction. So means that we have to start from the reactant. So once the reactant able to climb or achieve this energy, then only they will produce the products. Okay, so from the reactants up to the top of the energy profile diagram, this is called activation energy. While for another one, which showing the endothermic process, similar with the exothermic reaction. If we want to determine the activation energy, it is always involve the reactants up to the top of the energy profile diagram. So from here up to here, this is represent the activation energy for this endothermic reaction. So basically, we can say that activation energy is the energy barrier that must be overcome by the reactants before they can form the products. Okay, again, means that the reactant must climb up this mountain. Okay, we call this is mountain. Then only up to the peak here, that only they will able to form the products. Now we are in the third learning objective, transition step theory. Okay, basically when we want to describe this theory, we will use this energy profile diagram. So the condition at where the colliding species at the highest potential energy in the energy profile diagram is called transition state. So it means that at this position, the condition will be known as transition state. However, the molecule which at this transition state will be known as activated complex. Okay, so basically it's also referred to the highest potential energy here, but we will have two terms in here. If it is referring to the condition, this condition is known as transition state. But if it is referred to the species, so we will know that this species as activated complex. Activated complex. So again, recall back the previous slide. In the transition state, the activated complex is found. So again, transition state is referred to the condition, while the activated complex is referred to the species. So what are the characteristics for this activated complex? Generally, it is very highly unstable because it is possess highest potential energy based on the energy profile diagram. Second, it is only temporary because the activated complex will either return back as reactants or form the new products. So generally, based on this energy profile diagram again, we will notice that activated complex always has greater potential energy than reactants and products. Lastly, like what mentioned before, the activated complex either will form products if they have enough energy and also collide with the correct orientation. However, if they cannot fulfill these two requirements, therefore, effective collision is not happen and the activated complex will fall back to form reactants. Let's look at this energy profile diagram and answer a few questions. So as we know, at the left hand side here always refer to reactants, while at the right hand side here is referred to products. So now let's look at this question. Question A, identify the type of reaction based on the energy profile diagram. So when we look at here, we notice that the reactant release energy. Reactant release energy. So this reaction is exothermic process. Next, the EA label is referred to activation energy of the forward reaction or reverse reaction. So let's see what happened now. So as we already know that activation energy is referred to the energy gap in between the reactant with the activated complex. Okay, I simplify with AC for activation complex and R is the reactant. So because of this process here referring here, this one is forward. Forward means move to the right. So that's why this activation energy is referred to forward reaction. Forward activation energy. So how we identify the reverse activation energy? So like just now we mentioned that activation energy basically is the distance between the reactant and also the activated complex. So reverse means that we are going to move from the right to the left. So in this case, the product basically will become the reactant, and then the peak here or the highest energy over here still the same. So at here, the product in this case is act as the reactant. So again, the distance between reactant and activated complex will be considered as activation energy. Because of this reaction is reverse reaction, therefore, this activation energy also will known as reverse activation energy. So to keep in mind that forward activation energy, okay, activation energy, A is stand for activation, E is stand for energy, always different from reverse activation energy. However, always keep in mind that how we identify the activation energy is based on the distance between the reactant and also the activated complex. Next, label the graph with delta H, which means is the energy change. So the energy change is referred to the distance between reactant and product. Therefore, in this case, the distance between reactant and product will be labeled as delta H. Let's proceed to another example or another exercise here. So this one is the activated complex. The species at the highest potential energy is known as activated complex. So the distance between reactants and the activated complex, because here is referred to the forward reaction, so we can just label this as the activation energy. However, if the distance is between the products and also the activated complex, means that the reaction is moved backward or reverse reaction. So this activation energy will known as reverse activation energy. Next one, the difference between the reactants and the products will label as energy change, which is with the symbol of delta H. In this case, the reactant is absorb energy so that its products, so that the potential energy of products is higher than reactant. So we know that the reactant is absorb energy and the delta H will be in positive value, which is referred to endothermic process. Now it's time to proceed to tutorial question. Let's start with objective question, tutorial 7. The reaction C4H10 will produce C2H6 and C2H4 has the activation energy 350 kJ per mole. When the question didn't mention forward and then they just write down for activation energy, basically is referred to forward activation energy. While the activation energy for the reverse is 260 kJ per mole. As we know here, the activation forward is higher. So we are going to roughly sketch the energy profile diagram. These are the reactants at this energy level. So they will climb up to one peak and then produce the activated complex. So at here, basically, the the activation energy based on the question is 350 kilojoule. So this one is referred to, reverse reaction is referred to 260, so means that it will be at higher point. So go to here, and now here is referred to products, and this difference between the products and the activated complex is 260 kilojoule per mole. So from here we know that the energy of the product is higher than reactant. So this process is an endothermic process. But don't forget, the question is asked us to estimate the delta H, which actually is the difference between the reactant and also the product. Okay, so these are the value that we need to find out. Because of the reactant, the distance between reactant and activated complex is 350. And then now we minus with the 260 kilojoule, and here we will know that this is the difference between reactant and product, and is 90 kilojoule per mole. So that's why the answer is B. Now this is tutorial question number 10. A, define the activation energy. Basically, the keyword is activation energy refer to minimum energy required to initiate a chemical reaction. B, sketch and label a potential energy diagram for the following reaction. So for the first one, when we see this, the delta H equal to negative, we know that this is exothermic process, while positive, we know that this is endothermic process. So if exothermic process, before we continue, we have to label the graph. Here, y-axis is referred to potential energy, always in the unit of kilojoule per mole, while the x-axis is the reaction progress. So like just now we say, we already know that for B1 is referred to exothermic process, means that the energy of the product, okay, is released energy. So that's why the energy of the product is lower than reactant. Okay, so that's why you can start with any point, but basically later you have to make sure you have space to show that the product has lower energy compared to the reactant. Okay, but because of this question, let us know the species or the reactants and products in the question. So we are not going to use general terms product. We have to change according to the question. Here you need to write down SO2, while the reactant is solid. Sulfur in the solid form, and also oxygen gas. Don't forget the physical step over here. Okay. Then again, because they give us the delta H, so you have to label over here this value. Delta H is equal to negative 296.06 kilojoule. Okay, so similar case will happen to question B2. Only for this time, okay, I just make it faster a bit. This time, because it's endo, means absorb heat. So the energy of the product need to be higher than reactant. Okay, so in this case, it's 1/2 Cl2 gas, and then this one is Cl gas. Okay, so same case as well, you have to label potential energy in kilojoule per mole and also reaction progress. Okay, last part of this question is asked us to indicate the change on the diagram if the platinum is added. Okay, so we need to know that what is the function of the platinum in this case. Basically, the platinum is play the role of catalyst, okay, which we will going to discuss in 8.3. So for 10B, we stop over here first. Last tutorial question that we will going to discuss in this video, question 11a. State the two requirements for the effective collision. While B, with respect to above, explain how the reaction rate will change. Question B will be discussed in video 8.3. So what are the two requirements? First, because the collision always refer to the reactants. So that's why in your answer, you need to share the idea, the reactant molecules collide with correct orientation. This is the first requirement. Not just with the correct orientation, but the reactants molecule also need to possess the energy which is equal or greater than the activation energy. So these are the two requirements for effective collision can be happen.